Okay, this one's probably going to be pretty short. That's okay. So we were saying, what do you do, and in this in-between region, I've got a Reynolds number out at the length of the plate between this 5 times 10 to the 5 and 1 times 10 to the 7. It's basically between 500,000 and 10 million. What do we do with that? Well, if that's the case, if I've got 5 times 10 to the 5 is the Reynolds number computed at length L is greater than that, but less than 10 million. 10 times 10 to the 7. 1 times 10 to the 7. So between 500,000 and 10 million, if I get Reynolds number at the end of the plate in that range, they're saying just simply use a coefficient of friction across the entire length, the average coefficient of friction across the entire length, that this expression here will work just fine. They're saying take 0.074 divided by the Reynolds number raised to the 1/5 root, that's the Reynolds number out at the length raised to the 1/5 root, minus this other quantity, 1742, divided by the Reynolds number computed at the length. And I think I've got, sometimes I'll assign a problem where you find yourself in that position. You get a long flat surface. Again, this is only for flow over long flat surfaces, because when I've got a long flat surface, there's not much pressure component. Basically, the textbook, the drag coefficients you look up in the textbook, they're basically accounting for the pressure component for the most part. As we said, at the higher Reynolds numbers, most of those tables are for high Reynolds numbers. We're saying at the higher Reynolds numbers, the friction component becomes negligible and the pressure component is really the main driving factor. But if I'm dealing with a long flat surface, we're saying that pressure component actually becomes negligible and the friction component is the main component here. And so this is how we would find the coefficient of friction. We would find the coefficient of friction. We'll say if the entire plate is laminar, we'll say the Reynolds number at the length is less than 5 times 10 to the 5. Use this for your average coefficient of friction across the entire length. We're saying if the Reynolds number is greater than 10 million, 1 times 10 to the 7, use this as your coefficient of friction for the entire length. And if it's in between, use this. But again, that's long flat surfaces are a special case. Anything else, we're going to go to the table in the text, and we're going to try to find a drag coefficient that makes sense for the object that we have, or is a close approximation for the object we have. Anything that's not a long flat surface. And if we can't find a good drag coefficient, or if we need something more exact than what we have in a general table, then we actually need to measure that. So we can go in a wind tunnel, build a scale model in some kind of a liquid tunnel. Sometimes we can go look it up. I do know that some car manufacturers will typically publish, or at least you can look up, people have measured the drag coefficients or found and published the drag coefficients for different cars and different car bodies. So you can find those sometimes. But again, those are not long flat surfaces. This is what we do for long flat surfaces. It's the special case. Okay guys, that's all I like to talk about in Chapter 11. That's all we really need to talk about for Exam 3 is Chapter 8, pipe friction, both major and minor losses. Chapter 11, drag forces, including long flat surfaces. And that's really it. So I guess at this point I need to make up a review for Exam 3 video. Let's see, you guys have homework due. You got homework due this Wednesday, and you got homework due, I think, the next Wednesday, and then we'll take the exam shortly after that. So it'll be real close to the final. Everything kind of got moved back on us, but anyway, I'll get you some more information about the schedule as we get a little closer. But this should get you finished with the Chapter 11 homework one that I believe is due next week. Let's look at that and make sure. All right, guys. Have a good weekend. Email me if your questions. Find me in the chat. Let's set up a Zoom session if you like. If you guys, if that would be helpful, just let me know. All right, guys. Have a good one.